So today's video is on green chemistry and the 12 principles of green chemistry. So first we'll have a look at the definition. So green chemistry is developing chemical processes that are as environmentally friendly and sustainable as possible. So when thinking about green chemistry, the two key points to think of are environmentally friendly and sustainable. However, when developing a chemical process, we're not just thinking about the environment. We also have to take into consideration cost, impact on the environment, of course, which is our green chemistry, and health and safety. So this is of the workers, and this can also be including the environment around them. So there are 12 principles that help us to make chemical processes more green. So when we say more green, this is more environmentally friendly and more sustainable. So the first principle of green chemistry is atom economy, and this is the proportion of the atoms in the reactants that are formed into useful products. So this is how many of the atoms in our reactants actually form our useful product and how much goes to waste. So how does this impact our green chemistry? So if we increased our atom economy, it means that more of our feedstock, so our raw materials going into our chemical process, would be incorporated into the products. So this higher atom economy, more of our atoms in our reactants being converted into our useful products, means that we get less waste. So this makes it more environmentally friendly because we don't have to dispose of this waste. It overall makes it a more sustainable process. And it also means that less feedstock is required, because if less of our atoms are going to waste, more of it's going to the product. So we can use less feedstock, less reactants in the long run. So our second principle is waste prevention. So preventing the production of waste is better than having to deal and dispose of the waste in the first place. So developing a chemical process that doesn't have waste is better than learning to dispose of waste that you produce. So how does preventing waste impact green chemistry? So waste prevention means that less harmful waste is created to pollute the environment. So less waste that can harm the environment is produced, so there is less impact. So it's more environmentally friendly, more green. And also means that less energy is used to dispose of the waste. So less energy produced means that we're producing less pollutants to produce this energy. So this is more environmentally friendly as well. Our third principle is synthesis. So this is using less harmful chemicals in our chemical synthesis. So how does using less harmful chemicals impact our green chemistry? So less hazardous chemicals in the chemical reaction means that less harmful impact of the waste products. So 9 times out of 10, if we use safe chemicals, we won't produce as harmful waste products. So these will not go on to harm the environment. They'll be more environmentally friendly. Whereas if we use really toxic, corrosive chemicals, our waste products are more likely to have a damaging effect. Using less harmful chemicals also means it's safer for the workers. And it's safer if spilled. So our fourth principle is product design. So this is designing your chemical process to achieve the least harmful or hazardous products. So how does having less harmful products impact our green chemistry? So the less toxic and hazardous our products are, this means the less harm they can do to the environment when they're used, which is pretty self-explanatory. It is safer for the workers who are conducting these chemical processes, and it means there is a cleaner disposal. So if we do need to dispose of these products eventually, they will not be as harmful to the environment when they are disposed of. So our fifth principle is our solvents. So our solvents make up most of the chemical waste in chemical synthesis. So the waste production is very bad because we have to dispose of this waste, and solvents make up most of this. And our solvents are mostly flammable, toxic, or corrosive. So they're very harmful to the environment. They also contribute a lot to air and sea pollution. And this is because most solvents are very volatile, so they evaporate easily, so can contribute to air pollution. Or they are very soluble, so they will dissolve in water and cause sea pollution. So overall, our solvents aren't very environmentally friendly. So we use less solvents. So what is the impact of using less solvents on green chemistry? It means, well, developing solventless processes decreases the waste we produce, so decreases the energy we need to dispose of this waste. It decreases the risk because they are usually flammable, toxic, or corrosive, so it's safer. And it reduces our impact on the environment because they're less likely to contribute to more air and sea pollution. So number 6 is using less energy. So using less energy and developing processes that require less energy. So for example, this is processes that require lower temperatures and pressures. So what is the impact on green chemistry by using less energy? So the less energy used means that less pollutants are produced when we produce this energy. So less carbon dioxide from power stations, for example. And so number 7 is renewable feedstock. So our feedstock is our reactants that we feed into our chemical synthesis. So we start if we start using renewable feedstock instead of non-renewable finite resources. So what is the impact on green chemistry when we use renewable feedstock? It increases the sustainability of the process because we are using a replenishable source. We're not going to run out anytime soon. And it also means if we're not using as many non-renewable resources, we're not depleting our natural resources more. So this is good for the environment because we're using resources we can replenish. We're not taking natural resources and not replacing them. So this is very environmentally friendly. So number 8 is reducing reagents. So this is reducing reagents and the steps of a chemical synthesis. So we want to make the process as simple as possible, have the lowest amount of steps we could possibly have. So what is this impact on green chemistry? Having the simplest process, the simplest number of steps as we can. So this means that we reduce the waste produced from the different stages. So if we just have one stage in a chemical synthesis, we'll produce one lot of waste. Whereas if there were many steps, we'll produce waste along the way. So we're reducing the waste produced by reducing the number of steps and reagents introduced. Number 9 is catalysts. So if we use more catalysts and more selective catalysts. So selective catalyst means that it's specific and more effective to your reaction. So what is the impact on green chemistry when we use catalysts? So catalysts lower the activation energy by providing a different reaction pathway. So this means that less energy is required. So less energy is required to initiate this reaction because the activation energy is lower. So the less energy required means that less harmful pollutants are created when we produce this energy. So we're producing less pollutants by producing less energy. And using catalysts generally produces less waste, and this is because we can reuse our catalysts. So for example, if we needed to introduce another reactant to increase our rate, there would be a waste product produced by this introduced reactant, whereas catalysts can be recovered unchemically changed. So we can just keep on reusing them. They won't form a waste product. We can just take them from one reaction into the other without producing a waste. Number 10, so we design the chemical products to degrade into safe chemicals in nature. So we design our chemical products so that they degrade in nature. So what is the impact of producing chemicals that degrade? So this means that less harm is done to the environment because the chemicals don't pollute for a long time. So for example, plastic. Plastic is very bad for the environment. It's because it doesn't degrade, it just sits in the environment and continues to pollute for a long time. Whereas if we produced chemicals that do degrade, they will have a less long-term effect on the environment. So it's less harmful to the environment, it's more environmentally friendly. Number 11 is analysis and monitoring. So we design processes and techniques to analyze the chemical process in real time. So when the chemical reaction is happening, we are analyzing it. So we're better monitoring our reaction. So what is the impact on green chemistry when we better analyze and monitor our chemical synthesis? So our better monitoring can lead to reducing the waste products. So if we see more waste products being produced, we can alter our reaction. So we can develop our reactions quickly if any problems or issues are spotted. So if we see that we're producing too much waste, we can alter our chemical reaction. We can learn that we need to develop it. So, and lastly is number 12, which is safety. So this is using safer chemical processes, and by safer we mean processes which lower the risk of exploding, releasing harmful gases or catching fire. So what is the impact on green chemistry if we make our chemical processes safer? So minimizing the potential risks means that it's safer for the workers who are conducting this chemical process. It is also less likely to damage the environment due to accidents. So if gases were released by accident due to an explosion or releasing harmful gases, it will introduce these chemicals to the environment, which will harm it. So we're being more environmentally friendly by reducing the risk of damage to the environment.